In the first design challenge, students are faced with coming up with what's the best shape for the satellite design. In the second design challenge, they're now going to have to figure out how to configure their 4 satellites to fit best into the rocket that will take it into space. In Design Challenge 2, you want to give students the container first and ask them to construct the largest 4 satellites they can that will fit into the container that you've given them, that also meets the shape design that they came up with in the first design challenge. In the instructions in the MMS book, it suggests that you could use a potato chip can in order to use that as a container that will take the satellites up into space. What I did was I used a 2-liter bottle and I cut the top off just as a place, and then the students will have to stack their satellites within here and make it so that it will be able to launch into space. So the goal for students is to build the 4 largest satellites that can fit into this container, but also have the shape that they determined that was best from the first design challenge. Or you could tell students there was an octagonal shape that the MMS team came up with to launch into space. In either case, what's key is giving students the container first and telling them to construct satellites to that appropriate size. You may want to consider giving students an opportunity to take a look at the actual design for the MMS. I went onto the MMS website and I was able to print out this photo, which you can cut out and then fold down to become the shape of the MMS satellites. And in fact, I did it with this one, and I have one here that has a top and a bottom so that students could actually get a sense. And then I would take this and perhaps I would fit this into the container that I have in order to just demonstrate to them after the fact of what a possible solution might look like. But in any case, as students go through the design challenge process, you want to remind them to be keeping a log or a journal of all the work that they're doing so that there's a record of their work. And in addition, you want to have them collecting images and video along the way so that they can present a product at the end, such as a video, a poster, a blog, or something along those lines that will describe what their answer to the design question is. And finally, although a 2 or 3D fabricator would be a great tool to be able to complete this work with, if you don't have that, you might just consider giving students clay as a way to model their satellite design, or having them use rigid folds in paper to do the same type of thing in order to stack the satellites into the container. Don't let the fact that you may not have access to the fabricator hold you back from giving students this design challenge.